So what we're going to do is let's plot the points on this one. So hit the plus button and we're going to add a table. Okay. And so what we're going to do is we're going to plug in some numbers here. Now, what do you think the vertex of this particular graph is? If it's h comma k, what's h, what's k? I hear it. What do you think the vertex is? What's the point?
The vertex.
Yeah, but what is it based on the formula? No, that's the a value. What's the h? Look in your notes. You just wrote it down, right? And that's not -3. What's the h value? Well, so remember that this is written in what we call the vertex form. So it's a times the quantity x minus h squared plus k, right? And I'm not going to add the sliders yet. So what's my h value? Well, the formula has a minus sign in it, right? So remember that if I put -1 in here, then that, so it's a +1, right? Now, what is the k value? 3. So this vertex should be right here. Now, what does the -2 tell us? Which way it goes. Is it going to open up or is it going to open down? Down, because 2 is negative, right? So now let's think of a number close to this one. Actually, let's plug in 0. So go to, and you could use your fancy calculator if you want to. -2 times the quantity we're plugging in for x. So we're going to say -2. Then for x, we're plugging in 0 minus 1 squared plus 3, right? So when I plug in 0 for x, I get 1. Do you guys see that? So I get 1. So what I'm going to do is when x equals 0, I get 1. All right. Let's go. There should be a point right here, right? Because if this is the vertex, then we'll have a line of symmetry. So that line of symmetry, imagine a line that goes right down this line. So if there's a point here and it's 1 unit away, I should have a point here. What's that point on the graph? What's this point right here on the graph? Other way around, 2, 1, right? So I'm thinking that if I plug in 2 for x, I should get 1, right? Let's see. Let's plug it into the formula and see. So if I say -2, parentheses 2 minus 1 squared plus 3, hey, I get 1. Does that make sense? All right, let's do the next point. So the next point this way is what number? -1. Let's plug that in our calculator. Yes?
I got 5 for the equation when we plugged in 0.
when you plugged in 0? Where's your square? You forgot the square. You forgot the square of the thing.
I was like, this is wrong. Okay.
So we're going to do -2. And now for 1, we're going to plug in -1, -1. Make sure you get the right signs or you'll get an error. Plus 3. Well, I get -5. So when x equals -1, the math cranks out a -5. Whoops. 5. Okay. Now imagine there's a line of symmetry that goes right here. How many units away is it from that line? 1, 2. So this imaginary line that's right here should go 1, 2. So I should have a point here at 3, -5. In other words, when I plug in 3, I should get -5. I should. Let's see. Take this formula 2, 3, or I'm sorry, 2 parentheses, -2 parentheses 3 minus 1 close parentheses squared, shoot, wrong one, plus 3. Hey, it's -5. That's no accident. Okay. So then remember I was talking about this, what's the x value of this point here? 1. So the line of symmetry is always going to be x equals 1. The x value of the line of symmetry. And you guys don't know this yet, but you can go in here and change that to a dotted line like that. So that's my line of symmetry. Now watch what happens when I turn on the graph. Okay? Any questions? Now wait, I'm not going to stop the video just yet. Let's plug this in and watch the transformation. So remember that the parent function occurs when h equals 0 and k equals 0. So this is basically y equals x squared is that green line, right? So when I change, watch what happens to the graph. When I change a to -2, watch what it does. It compresses it, and then when it becomes negative, it stretches it in the other direction. Vertically, it stretches it downward. Then my h value is 1, so